Okay, so why do we need a mathematical model of federated learning? Well, a federated learning system, a real-world federated learning system, could be a highly complicated system. So, a federated learning system could involve supercomputers, training large language models. Uh, it could also include smartphones that run small or lightweight machine learning models. The smartphones might be connected via unreliable short-range wireless links like Bluetooth. Then we might also have laptops like the one I'm using now for recording this video, which runs some off-the-shelf Python package like PyTorch for implementing machine learning models. And a federated learning system might also include very small devices, like nowadays there are smart bulbs, which have some computational power and which might also collect data, like presence in rooms, so they know when to turn on uh, in advance, when to light up a room. Uh, Yeah, so there's a lot of details involved here. We have the physical properties of all the communication links. There might be very different types of links, like fiber communication links, fibers providing high-speed connections. There is wireless connections, wireless connectivity via mobile networks or via short-range communication systems like Bluetooth. So there are many different types of communication links, all with their own communication protocols. So we have different low-level protocols, and the devices are very different, can be very different. Device can be a small embedded system in a light bulb, or could be a supercomputer. All these devices typically use different operating systems, while some type of device, like a smartphone, they might only use one out of a few different operating systems. But we should think bigger here in this course and consider really arbitrarily large and heterogeneous federated learning networks. And the devices in these networks also typically use different computing software, for example, different Python packages. So one of you might use a smartphone, programming a smartphone using PyTorch library. The other one prefers to use scikit-learn Python package for machine learning. So there's a lot of versatility here and a lot of details. And we will ignore many of those details, or actually we need to ignore many of these details to make a useful analysis. And one way to abstract details is using a mathematical model. And one such mathematical model, or the main mathematical model in our course, will be a federated learning network. So federated learning network consists of nodes that are represented here by these filled circles or filled dots that represent devices. So each of these dots here might be either a smartphone. So this dot here might represent a smartphone, and this dot here might represent the supercomputer somewhere in Finland. And the network also includes links. So some of these devices are connected. So there's some connectivity. We model this connectivity, the ability for a smartphone to send some request to a server that is running on the supercomputer via an internet connection. This is condensed or approximated by this link or edge here. And we also assign a weight to the edge. This weight could be, for example, representing the capacity. So if the weight here, this number I prime is large, this means we can transmit a lot of bits per second between those two devices. Yeah, the important point is that this federated learning network is a mathematical model, and as any mathematical model, it's an approximation. So we only approximate this real-world system. So here is the real-world system, and we want to study it. We want to analyze it. And to analyze it, we need to ignore details because otherwise it would be intractable to analyze it. So and this abstraction, this pruning away unnecessary or details that we deem irrelevant, this is the federated learning network. And this, of course, incurs a modeling error. So depending on how we choose this federated learning network, incurring many design choices, we get a larger or smaller modeling error. And one of the main theme of this course is to provide you with some intuition how to make a good choice for this federated learning network in order to keep this modeling error uh, small enough.